All right, we're going to kick things off. Good afternoon, everyone. How's your day been? Excellent. Hope you're all enjoying the libations. But here we're here to talk about some science. So we have Jessie Smith. She's a biochemist who started her brewing career at Houston's St. Arnold Brewing Company, where she focused on microbiology, sensory, and yeast propagation. Her next endeavor was to become a quality manager at Single Cut, Clifton Park. There she managed the lab and ensured quality of both single cut and contract beers from multiple brands. Following this, she established Queen City Quality, which is awesome, a lab testing service focused on breweries in New York State. In addition to third-party testing, she currently is quality manager at Community Beer Works and Thin Man Brewing in Buffalo. Take it away.
Thank you. Okay, let's see. Tell me if I'm too loud or too quiet. You're good. Well, thank you for coming. It's the last session, and it's hopefully not going to be too science heavy, but it is a science technical topic, so I'm going to try to make it easy on us. But yes, we're going to talk about growing and micro-programmed for your brewery. So just a little presentation outline. I'm going to go over the basics of microbiology, why you should even be testing, infections, if they show up, what they're going to look like as far as flavor, off flavors, mouthfeel, different types of yeast and bacteria. We'll talk about the media types, equipment, lab space, sampling points, and then how you can slowly grow your program. So if you don't want to see this broccoli thing in your beer, thank you for being here. You're going to find out how to not do that. So just a little bit of background. As Kristen said, I have a background in biochemistry from the University of Buffalo. My research was on genome stability, so that's what this protein is here, MUSH2, MUSH3. I said that a lot during those couple years at school. And brewer's yeast was my model organism. So I got very well versed with growing up yeast, manipulating yeast, counting yeast, all of that stuff. So I started growing an interest and then thought, okay, what if I hop into the brewing industry? I don't want to do academia, don't want to do a PhD, so let's try that. So first brewing job at St. Arnold's, a big focus was microbiology. And I came up with my own personal lexicon of what do we want to see, what don't we want to see, and what's like worst case scenario. Recalls could happen, exploding hands, which we'll get into. Okay, so like I said, it's the last session of the day. It's going to be a little alphabet soup. So I've scattered in some microbiology trivia, and we have some cool bottles as prizes. So I guess we'll do like a hand raising, or you can shout it out. Whatever you feel like doing. But here's our first question. Name dropped in Men at Work's Down Under song, what iconic Australian spread is a byproduct of brewer's yeast in the beer making process? I think I saw you first. That is correct. All right, come up and pick whatever you want.
When did you have it?
You did? And I didn't know that. So, learned something new. And here's a bottle opener. All right. So we're just going to go over some very basic microbiology overview. So microbiology is a scientific study of microscopic organisms. This will include bacteria, viruses, fungi, algae, and protozoa. What do we actually care about within that group? So viruses, we're not going to see that in beer. They need a host, a living, breathing, human, animal, something like that. Protozoa or parasites can't survive in alcohol. So that is the really nice thing about working with alcohol. We're not going to kill anyone. Where it's like food products, listeria and salmonella and stuff like that. So we can sleep a little better at night, but there are things that can grow. Algae is really only applicable if you're using spirulina, and that's usually an intentional addition. So that leaves us with bacteria and yeast. So we're going to be looking at wort and beer spoiling bacteria, those two different time points where they can start to grow and show up. And then wild yeast will be our other main category. So why is testing important? Why should you even be doing this? Again, beer is a pretty stable product. We have alcohol, pH, and hops. We're not going to get pathogens. We're not going to get anything that's going to make anyone overly sick, but there's still a lot of important reasons to be testing for microbiology. So the first step to preventing infections is knowing that you have one, knowing that there's an issue, being able to diagnose, here's an off flavor, is it coming from poor yeast health or is it a bacterial infection? So once you know you have something, diagnose where it comes from and be able to get rid of it. I'm not really going to get into too much of the weeds of finding the problems and how to solve them. A lot of it's cleaning. So I'm going to get into more of the testing and what you can do to start doing the testing. And then, you want to prevent it from happening again. There are certain, I'll get into it, but certain bacterial infections that love to spark in the beginning of summer. When it gets hot and humid, there's puddles in the brewery. So you don't want to keep trying to have that issue year after year. Usually an off flavor or mouthfeel issue, and these can be traced to bacteria and yeast. Some can still survive in alcohol, hop environments, and some are pH tolerant. So we have that metric of, okay, things can't survive in alcohol, but there are some, especially lactobacillus, that are really hardy and scary. So we still need to test for them. We have both the presence or absence of oxygen. So that takes us across the board. We've got fermentation side and then packaging as well. Fun fact, this is pink slime that's kind of found around canning lines and stuff like that. So that could get into your beer or on your cans as well. But I thought it was cool under the microscope. It's cool. So another big thing is financial implications. So we probably remember in 2015, Goose Island had a lacto infection in Bourbon County Stout. There's a book, I think it's called Stout and Selling Out or something like that, and it's about Goose Island selling, and then this is highlighted and how this infection came about. And they had 2 different facilities, a lot of different, moving points, and how this kind of came about. But it was just a lactobacillus infection, something we work with a lot. But ended up, they don't have it fully disclosed, but they ended up having to pay back customers. So the full price point isn't fully disclosed, but it was a pretty big hit for them, not just financially, but also their reputation for their customers. So financial implications as a whole. You want to prevent recalls. Obviously, it's a lot of money, but it's also a lot of processes and things. So if you've never done a recall, it's a much bigger thing than just paying the customers back. You want a consistent product, and you want to keep your customers coming back. So preventing these infections is a financial way to kind of keep you sound. Oh, look, we have another trivia question. Okay, so what bacterium, better known in its partially abbreviated name, is gram-negative and rod-shaped? It had a famous outbreak in 1993 when Jack in the Box spread it across 4 states. Yes? Sorry. I'm just going by, in my peripheral, the first hand I can see up. So if you want to come up and grab a bottle. So, yes, E. coli. E. coli is a big one in food products, spinach and things like that. It's very, very rare for it to show up in beer, but it can. It has E. coli, salmonella, but it has to be a very special soup for this to happen. But again, that's one. We don't really have to worry about that as much in beer. So just an overview of the issues that we can see. So obviously off flavors, things that aren't true to brand, things that we don't want in our beer. So vinegar, butyric, diacetyl, lactic acid, sourness, DMS, and then any sulfur, rotten egg, struck match, things like that. Those are usually with bacterial and wild yeast infections at high enough levels that they're off-putting. Mouthfeel, if you've ever experienced a ropey beer, it's one of the most disgusting things. It's just all these strings, and so ropiness, turbidity, viscosity. Some beers get kind of syrupy, so when you pour them, you can see it's getting a little thicker. And then if you have pellicles in your beer, that's so scary. That's more of a kombucha thing where they want to see those. But the bacteria we're going to talk about can have those impacts. And then obviously the packaged product. Exploding cans is my nightmare. Foaming or gushing cans, or increasing acidity throughout the shelf life of the beer. And we'll get into the bacteria and all the yeasts that do that right now. So yeast. Brettanomyces. So in some instances, we do want to see this in our barrel-aged programs and our funky beers, but in our lagers or our IPAs, we're not going to want to see this. I'm going to give an overview over a few types of yeast and bacteria that might show up and what you could test for. So Brett, it's going to produce acetic and isovaleric acids. So isovaleric is that cheesy, sweaty hop kind of aroma, but yeast can produce it as well. It's aerobic, so we'll see it fermentation side mostly, and in barrels and things like that. They're gonna ferment most sugar. So we'll get into diastatic yeast, but Brett will be able to chew down more sugar. So re-fermentation could be something that could come up, but they're just gonna eat everything that brewer's yeast leaves behind. They can also metabolize ethanol. They are pH sensitive, so if you have Brett in a sour beer, they might not do as well, but they're very slow growing. So this could be something where, and we'll talk about with diastaticus, you have a creeping fermentation. It just keeps going down, and you might not notice it. You might have, okay, I had a repeating gravity, I'm gonna crash that tank. You can that beer, and then it'll just keep going down and down and down. So it's one of those things where I think the yeast ones mostly are the ones that are very slow, very easy to miss when you're just looking at fermentation data. So that kind of ties into diastaticus as well. So this is where we see re-fermentation in cans. Lots of exploding cans, fruited, sours, things like that. Because again, this is one that's going to eat all of those small sugars that brewer's yeast leaves behind. They're gonna eat everything. So this is where you can see slow, creeping fermentations, able to metabolize a wide range of sugars, and they also outcompete brewer's yeast. So then let's say you have a diastaticus infection in a tank, and then you don't clean it enough, or it lingers, your next beer, it's going to outcompete the brewer's yeast and just completely take over. And that if you don't notice it, it'll just keep going and going, and it's really tough to get rid of. This is kind of a lesser known, but a very strange one. Wickerhamomyces, or Pitchia. This one's anaerobic. So we're gonna be seeing this more later fermentation, packaging. It'll grow to low pH. So your lighter beers, your sour beers, it can still grow. This one is considered a killer yeast strain. So this secretes toxic proteins that kill other yeast. So kind of like with diastaticus, how it outcompetes brewer's yeast, this will just kill it. So again, if you don't clean it properly enough, it's going to just kill your brewer's yeast, and you'll have no fermentation if you don't clean this out well enough. Those toxic proteins can also show up in souring yeast strains. So it's another kind of like cleaning incentive. But this one, it does a lot of stuff. Cloudiness, gushing, funk and phenolics, just a lot of things that your light beer, your Pilsner, and you don't want to see any of that in there. Okay, now on to bacteria. I've got 4 types of bacteria here. We know lactobacillus, pediococcus. Sometimes we want to use that because it gives us lactic acid production for our sour beers. However, in certain conditions, and pediococcus specifically produces diacetyl. So a lot of barrel-aged beers, pediococcus will kind of take over, and you'll get some of that diacetyl. But both of them together will create a ropiness in beers as they sit over the shelf life, and they're hop tolerant. Most strains of lacto and pedio have you can use some IBUs, but they're pretty hardy. And I think over time they've kind of progressed where they're more and more resistant, especially the ones that we use in the brewery setting. So just using hops and IBUs isn't going to be enough to make sure this isn't present. Our acetic bacteria, so this is our vinegar. Again, barrel-aged beers sometimes, but it can show up in our other beers. Ropiness, it'll create an over-oxidized environment within the can or bottle, so that'll increase your oxidation risk. This one's aerobic, and this one is completely hop resistant. So really, really tough to get rid of once it's in there. Enteric bacteria. This is one I don't think a lot of breweries know about. I think it's one where it's there, but you don't necessarily know. And if you're not testing for it, you're never going to see it because it has very subtle off flavors and issues. So enteric bacteria, often found in water supplies. So this is the one where I tell breweries, test at the beginning of the summer because that's when it's going to be hot and humid. You're going to start seeing this stuff and know, okay, where are my trouble points with this bacteria? This one is a wort spoiling bacteria. So it'll start to grow in wort. It really won't survive with alcohol. So that's the nice thing. It will die off with alcohol content, but at that point, you do have issues already with it. You've got vegetal off flavors that it created while it was in the wort, parsnip, carrots, that kind of stuff. It can do a lot of fusel alcohol content. And the major thing is it creates a biofilm. So with this bacteria, it'll just start, if you don't clean your tank properly the first time, it'll just keep coating it and coating it. So then it takes more and more for this to eradicate it from your brewery. And it likes lighter beer style. So then those off flavors, it's a little easier to pick up on those. But this is one where it's hard to get rid of it once it's in your tanks, but very easy to avoid. And Megasphaera pectinatus. Has anyone heard of this one? This one is, I think it's going to become more relevant for breweries. Up until recently, it's only been for the big guys, Anheuser-Busch, things like that, because they're able to get their DO levels down so low that that's where this bacteria thrives. So it's anaerobic. It thrives in those oxygen-deprived environments like the nooks and crannies on your canning line. Again, it's very slow growing, but it creates the most terrible combination of sulfur and butyric acid. The first time I experienced this in a can, it was just, it hits you in the face. It's horrific. And again, it's slow growing. So the way I experienced it, we had a Kolsch. Our Kolsch and our Summer Ale. So it was like 3 months into the shelf life. And we were like, oh, we're getting reports of these cans. We opened them in the brewery. We're like, oh my God, this wasn't like this even a month ago. So this is one you can't necessarily test for it right away. It's slow growing. So if your beer's at a gas station, in the hot, cold environments, that's where it's going to grow, and you're not going to know until 3 months. And again, it's getting your DO levels down, which we want. That's a wonderful thing, but then they're in the canning line already. So then when you have your DO levels down, you have a low alcohol beer, low IBU beer. They're like, yeah, let's grow. So that's sulfur, butyric, and then turbidity as well. Trivia 3. What is the name of the neurotoxin produced by the gram-positive bacterium Clostridium botulinum? This neurotoxin is used for cosmetic purposes. Yes. Botox. Come and get your beer. Okay, so now we're going to get into some of the lab heavy stuff. So that was kind of a yeast bacteria, a little bit of a fear factor. Here are the things that can happen in your beer. And I will say with all of those yeast and bacteria, some of it's across the shelf life. They can get worse and worse, like that Megasphaera pectinatus, where you won't know until it's out in the public. And then it's either a recall situation or it's something where your customer doesn't tell you because they're like, oh, well, I'm never drinking that again. So there's real implications for having all of those present in your beers. Okay, so I'm going to talk about the 3 types of media that I use the most. There's a bunch of media types out there. There's ones for water testing. There's ones that kind of fine-tune some of these things. But through my experience, I like these the best. They kind of avoid some false positives, and you can do a lot with identification just with the media without having to do further steps. So our first one is HLP, Hughes Lactobacillus pediococcus medium. Shocker, it tests for lacto and pedio. This one you're going to want to do in tubes because it creates that anaerobic environment, which is where your lacto and pedio is going to grow. So yeah, you're going to be detecting lactic acid bacteria, making that anaerobic environment. Lactobacillus will show up as inverted teardrops, like that picture from the Bourbon County slide. They were kind of like they had a little tail to them. And then pediococcus, they're just very round, circular. So you can do identification just based on what's in the tube. Also the time points when they grow. So with all of these media types, I like to test them hold them for 96 hours. So at 24, 48, 72, 96, I just check them, do a visual. With these ones, if I saw something right away at 24 hours, I know it's bad. They're fast, they're growing, they're healthy, and then they're going to fill up that entire tube. These ones expire after 2 weeks, so you just have to remake them periodically. I'll get into a little more about some of the supplies, but this one's probably the most approachable to breweries. You don't necessarily need a pressure cooker for it. You just need the media, and it ends up being about 87 cents per test. And then the last bacteria, Megasphaera pectinatus, this one can show up in these tubes. It's not meant for it, but it can show up a little bit in that top layer. So let's say you get a can back, it smells terrible, it's got that turbidity. If you do this test, you'll be able to see, you won't see those lactopedio colonies, but you'll see a layer at the top. It'll be like, okay, there's something in here. The other thing with this media, you can't pull colonies out of it. Once they're in there, it's just a visual. Let's say you wanted to do further identification or use the colonies for propping or something. These ones, they're in there and they're done. Okay, our next media type is LCSM. Like I said, it's a little alphabet soup at this point. Linz cupric sulfate medium. So this one you're going to use for Petri dishes, and it's going to be aerobic. So this one is testing for non-Saccharomyces wild yeast. So this is going to be our Brett and our diastaticus. Copper sulfate is added. So this is adjusted to inhibit brewer's yeast growth. Because if you just had everything growing, it wouldn't be super useful. It would probably be terrifying if you plated it and it's just full of everything. So this specifically is for the non-Saccharomyces, what we don't want in our beer most times. I will say there's some Belgian strains that are diastaticus positive. The manufacturer should say on their packaging and on their website if it is a diastaticus positive strain. So if you were to plate those, they'll show up on this. But that's also a good check to say like, okay, I was expecting this to grow and it grew. These ones you can't identify the colonies based on the shape and size alone. They're all gonna look like just a little white yeast colony. If you wanted to identify, you would have to do a PCR. But with this, the nice thing is, okay, we know it's Brett or diastaticus. That's still pretty bad. We don't want that in our beer. So usually the need for further identification isn't super necessary unless you're really curious to see what's going on in your beer. These ones expire after 5 days, so usually every week you're making them. And they're about 53 cents per test with the plate and everything. Then the last media I'm gonna go over is LMDA+. This is Linz multi-differential agar. So this one can be used for a couple different things, but I use the plus version to kind of specify it a little bit. Again, these are Petri dishes. This is going to be aerobic, and this will detect your wort and beer spoiling bacteria. So the plus is adding cyclohexamide. This is I think DNA denaturing agent, specifically for yeast. So it'll inhibit yeast growth. If you don't add the cyclohexamide, you'll get yeast and bacteria. It's kind of a base plate. You could, have everything growing on it if you wanted to. But the cyclohexamide helps because then we're just seeing what bacteria is there. And that was that picture in the first slide, that broccoli-looking stuff was on one of these plates. So this one, you can do a little identification. These will form, if colonies are forming acid, like acetic acid bacteria, they'll create a little halo around the colony. So you can use that to say like, okay, I know this colony's forming acid. Even if I don't know what it is, I don't want that. I know I don't want that in my beer. I know something's gone wrong with that. And then with this, it is a lot of visual morphology, kind of getting to know what the colonies look like, but you could also do a gram stain. Kind of like what our trivia questions are saying, that gram positive. That just helps us identify what the bacteria is that's growing. These ones are good for a month. So you can make a big batch and have them ready, and they're about 69 cents per test. Okay, so the sampling points that I recommend, from the fermenter, I like to sample 2 to 3 days after fermentation begins. If you were to sample like the very next day, or even the same day that you do knockout, it'd be too much yeast inhibition. You'd have the brewer's yeast, and it would kind of cover that plate where nothing else would grow, or you wouldn't be able to see what was going on. So this way, fermentation kicks off, but you'll still be able to pick up on the bacteria and wild yeast if it's present. So I recommend all 3 of those media types for pulling out of the fermenter. If you have a positive, I recommend to switch out your valve or do something where you can have another sampling point so you can rule out if it's your Zwickel or your valve or something like that. I'll get into sampling in a little bit here. So yeah, bright tank, and for the packaged product, I usually just suggest the lactopedia media. Those are going to be what's surviving and what's going to be the main issues. You can do all of them. You can test for wild yeast, but I suggest those ones for those steps. And I like doing bright tank and packaged product because let's say it helps me to narrow down where something comes up. Like, okay, I didn't see it here, but I saw it in the packaged product. I know it's coming from my canning line. Bright tank was clear. And then your shelf life. As issues come up, you get complaints, you can use any of those media. So let's say you're getting that megasphera, sulfur butyric, then you can use those HLP tubes, or you're getting exploding cans, God forbid. Then you can do your wild yeast and say like, okay, this wasn't here in the fermenter, but now it's in my packaged product. Where did this come from? And it helps you to identify and go back and find where it came from, how you can fix it, and then prevent it from happening again. Your lab space, it's going to be an area that's easy to clean. I know a lot of breweries don't have the extra space, but if you just quarter out even just a benchtop area, it could be mobile, it could be a stainless steel table, something like that, easy to clean. If you're able to close it off to outside traffic, let's say you have a brewery that's in a restaurant or something, having it in a little bit of a separate area can be helpful because then it helps minimize air movement, people walking by, things like that. I would say if you do have a lab space, avoid tiles and grout. Because going back to the LMDA media, cyclohexamide's pretty nasty stuff. It's a pretty toxic chemical, so you don't want that getting into your grout and never being able to fully clean that out. So I'm going to get into equipment in a second, but yeah, you want benchtop space for an incubator, and then you want space to be able to do the sterile work. You don't need a fume hood. You don't need anything too fancy. We're going to talk about Bunsen burners, but to have that space that you know is clean, that you're able to clean properly for making plates and for plating your samples is key. Okay, so equipment. I didn't get too much into the weeds with this. If you are interested, I'll have my email up and my cards. If you're really interested in implementing these, I can give you a list of the equipment you need and sourcing it, because stuff can be pretty expensive. So there's a lot of different options for sourcing these things. So the main steps, you're going to want to be doing sterile sampling. So you can't just pull a sample out of your tank willy-nilly. You want to make sure your port is sterile that you're pulling from, because again, that kind of narrows down, all right, it's not coming from this. My bacterial infection isn't from this point, it's actually in the beer. So I recommend a butane torch, one of the little ones. I see people that use the big ones and they, put it on their port and they turn it red. That's overkill. That's just gonna damage your ports. So just one of those cute little guys. Some swabs to kind of clean out your port and your Zwickel. You can use Q-tips, but just something that you're cleaning any excess beer off of that. Isopropyl alcohol, which you might already have in your brewery environment. So you spray that, and then sterile tubes to put your sample in. You want to know something is sterile so that it's not the sample container that's infected. So pretty much the method is spray it with ISO, swab, get the beer out, spray it with ISO again, flame it to kill off anything, flame off the ISO, and then pour off a little bit of beer, and there's your sample. So that's probably $50 for all those things. Again, you can get them pretty cheap, but that ensures that your samples what you're getting is coming from the beer. Making the media, that's probably the biggest hurdle. So you need the media and chemicals. So media usually comes in a powder form, so like our LCSM, and then the chemicals, the cyclohexamide. Those can run $200 a bottle, but you don't need much, so it can last you a long time. Petri dishes, those usually come sterile, so you don't have to worry about that. Again, sterile tubes for this step. The pressure cooker. So pressure cooker or autoclave, pressure cooker is more approachable for breweries. They can be, to get one that's kind of a decent size, because you can use it for other things too. You can sterilize your valves, you can sterilize water if you need to. I would recommend, getting an okay sized one. I think the one I have is 21 quarts. But it was a used one, maybe $300, $400. So you don't necessarily need to get a new one, just something that works and has a release valve on it. So that's important. And then things like Erlenmeyer flasks, stir bars, that stuff you might already have, or you slowly grow and, pick up some of those things. Like, oh, okay, someone's getting rid of their stuff, I'll take a couple of your flasks and your stir bars. So that's for making the media. That one, $875 up to $900 if you're doing all 3 of those tests. I'll get into, steps for growth in a second. And then plating the samples. Your biggest cost is going to be an incubator, but they're not terrible. They have ones on Amazon that are reptile incubators for like growing eggs and stuff, I guess. But those can be like $200. And you really just need to have one temperature setting on it. It needs to be able to, clean it if necessary. But yeah, there's a lot of different options. You don't have to get like a big fancy one. And again, the Bunsen burner method. You don't need a fume hood. You don't need anything crazy. A Bunsen burner works really well. And again, if you have that area that you're working in, you put the Bunsen burner in front, turn it on, and it creates a sterile environment. And you let it run for a little bit. It cleans the air in your working area. So Bunsen burner is a really good option, but you need your propane, the hookups, things like that. And then sterile transfer pipettes, getting your samples onto the plates and in the tubes. And then for the plates, there are spreaders. Again, it's a lot of like sterile work and all these little things that you need. So then for the plating step, that's about $400 in supplies. So if that seems like a lot to just jump into all at once, I would say you can start slow. Get some Erlenmeyer flasks, get a hot plate, things like that. But you could also start with HLP. This one's going to be the most approachable. You don't need the pressure cooker for this one. And that's the one I suggest using for the most time points. So it's a good one to start with and kind of get your feet wet, implement it, get used to making the plates and the tubes and things like that. I would also say implement media types as you need them. So let's say something happens, you get reports of exploding cans. Let's say you have all this, start getting the supplies. You're like, okay, we have exploding cans. Let's get that wild yeast medium and let's get that one started. And if you're not ready to test all of the time points, if you don't have the manpower or the time, I would say test beers that you think have issues or things that you're concerned about, either over the shelf life or like, okay, this is a creeping fermentation like we might see with Brett or Diastaticus. Let's test those ones and see if something actually is going on. And then I would recommend working up to all of those different testing points so you're getting everything across the board. Okay, a last trivia question. I love true crime, so I had to implement one of these guys. What was the nickname given to a New York cook who, because she carried salmonella, made people sick in the early 1900s?
I thought of Typhoid Mary, by the way. Yeah,
Yes.
Typhoid.
Typhoid? Mary, come in, grab a bottle. Thank you. Yeah, she used to make peaches and ice cream. I just picture her stirring it with her hand. But she was a carrier of typhoid, so she was convinced there was no issue on her part. Yeah, because she didn't have any symptoms, so she just kept going from place to place and changing her name. And eventually they had to institutionalize her because she just wouldn't stop cooking her peaches and ice cream.
Did you watch the Drunk History episode?
No.
They have a Drunk History. It's the best. It is so funny. She's like, I'm married.
That's how I picture it.
That's the so funny.
Okay, so almost done, for especially the last session. I wanted to keep it quick and have time for questions. So just my key takeaways. All of this stuff, and it's kind of a lot, but you're wanting to diagnose your infections, finding the source, preventing it from happening again. Because there's nothing more stressful than having the same issue that keeps coming about. Okay, we keep having our Pilsner with this parsnip off flavor in it. Where is it coming from? You're gonna have better consistency in your product because you're gonna know more about your product and what's happening. Less off flavors. Saving money on recalls and customer impact, things like that. And you're gonna sleep better at night. You're not gonna worry about that creeping fermentation. Is that gonna lead to exploding cans in a couple months or something like that? And then just my Queen City quality plug, if you are overwhelmed by this, feel free to reach out. We can do a trial micro program. So we can go through, diagnose the major testing points we think you need to work on, based on areas that might need more cleaning, things like that. Or if you think you've been having this recurring issue, we could try to narrow down where that is. So usually for new clients, I'll give a week of free micro testing. So that way we can see how many tests we would need to do, narrow down the areas where we might want to focus on. So yeah, thank you. There's my email and Instagram, and yeah, if you have any questions. Thank you for coming.
Any questions?
Yes.
Do you have any recommendations for dealing with potential sample bias with heterogeneity inside of the tank, or a false negative, or anything like that?
So you're saying things being at different points?
Yeah. So like if you're taking a sample from your sample valve, you're taking a sterile sample, and it's negative, but hypothetically you have something in this very shallow underneath or tank or something.
Most of the time, unless the beer is crashed, things are going to be pretty settled or, spaced out throughout. But yes, there is that potential for, I think, yeast, like wild yeast, could settle out. Even with the samples that I plate, I'll put them cold for a couple hours just to get some of the brewer's yeast to settle out, because again, there's that feedback. And you can still get wild yeast and bacteria in that part. So it really is pretty fluid especially that 2 to 3 days of fermentation. That tank should be going pretty good. But yes, there is that potential for that. So if you have big enough tanks, if you have multiple sampling points, that's something you could test out. Okay. Yeah?
I also have another question. What do you have recommended incubation temperatures for the different media, given that you're doing aerobic versus anaerobic?
What's nice is these can all be done at the same temperature. So I think I do 86 Fahrenheit, 30 Celsius. Again, it's trying to make it user friendly. So all 3 of these media types, I'll plate them all the same day, put them in the incubator. They're all 86. If I were to be trying to prop lacto or something, then I would mess with the incubation temperature. But for these media, that's, across the board. It works pretty well. Thanks, guys. If you have any questions, come find me.
Thank you.
Thank you.